Have you ever looked at the night sky and felt that something out there is quietly moving toward us? Not fast, not loud, just drifting, closer, every night. In this sleep documentary, 3I, Atlas, a strange fleet is closing in on the sun. You'll hear the real story of a visitor from another star and the strange companions that followed it. You'll drift through cosmic light, hidden rhythms, and the quiet hum between worlds. So close your eyes. Let the universe slow down with you. You're listening to Whisper Science. And before we begin, tell us softly in the comments from which country you're watching the stars tonight.
Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video.
They say the universe moves with a rhythm too vast for us to hear. Planets trace their endless arcs, moons follow their masters, and the sun itself drifts through the galaxy like a note carried by an unseen song. For most of history, that rhythm has been silent to us, steady, predictable, almost comforting. But then every so often something appears that throws the melody off balance, a single note that doesn't belong, something that whispers a new pattern into the cosmic harmony. In the year 2025, that dissonant note has a name, 3I, Atlas. Astronomers first noticed it on quiet nights, when the telescopes turned toward the outer reaches of the solar system. At first, it was just another faint smudge against the black, another cold traveler reflecting sunlight off frozen dust. But the more they watched, the more it refused to behave. Its orbit didn't loop like the others. It wasn't bound to the sun at all. It was slicing through our system like an arrow, hyperbolic, uncatchable, destined to leave and never return. That alone was enough to stir fascination. Yet what followed changed fascination into unease. As the months passed, observatories across the world began to notice coincidences, or what looked like coincidences at first. In simulation after simulation, in data sets from amateurs and professionals alike, something strange was forming around the arrival of this interstellar visitor. A cluster of comets, 17 in all, seemed to move in rhythm with it. Their orbits, usually scattered like seeds in a windstorm, appeared to pulse inward toward the sun as Atlas approached, then drift outward again once it began to leave. It was as if the solar system itself was breathing in sync with an intruder. No one wanted to believe it. Astronomers have seen illusions before, glitches in software, perspective tricks, patterns born of compressed time and human imagination. But the data kept repeating. 17 icy bodies tracing faint ellipses that seemed to bend together and release together, like dancers responding to an invisible conductor. Forums lit up with debate. Some insisted it was coincidence. Others felt something deeper, a tug, a pattern whispering that perhaps these comets weren't acting alone. When you stare at orbital maps long enough, the lines start to look alive. The great ellipses of planets, the fragile arcs of comets, all threading around a single burning star. And somewhere between them, Atlas, a small but defiant traveler that doesn't play by the same rules. Its path is open-ended, a one-way road through our neighborhood. It has no allegiance to the sun, no promise to come back. For scientists who spend lifetimes cataloging the familiar, this kind of object is a reminder of how unfinished our understanding really is. Atlas was first catalogued as C/SICE 2025 A1, the third interstellar object ever confirmed, after Oumuamua and 2I Borisov, but it differs from both. Oumuamua was a sliver of mystery, non-cometary, tumbling, reflecting sunlight without visible gas or dust. Borisov was more traditional, a clear comet with a long gaseous tail. Atlas sits somewhere in between. It glows like a comet, but its chemistry doesn't match anything we've seen. It breathes out gases long before sunlight should have warmed them. It shimmers with water vapor even in the frozen outer regions where most comets lie dormant. The instruments say it's alive when it should be asleep. NASA's early readings puzzled researchers. Water loss at nearly 3 astronomical units, far beyond the threshold of typical activity. Something inside Atlas was running hot. Theories spread. Perhaps its ices contained supervolatile compounds, or perhaps radioactive decay was releasing energy from within. But each possibility opened new questions. If it was formed around another star, how different must that environment have been to make a comet that wakes before the warmth reaches it? Then came the spectra. The James Webb Space Telescope, with its infrared eyes, captured the glow around the object, the coma, a halo of dust and gas. What it saw was startling. The ratio of carbon dioxide to water was nearly 8-to-1, a chemical fingerprint alien to our neighborhood. In our solar system, comets carry water as their soul. Ice is their heart. But Atlas seemed carved from a world where water was scarce and carbon dioxide reigned. It was a composition that spoke of colder skies and redder suns, of birthplaces far from anything we've mapped. The first whispers of something more came from polarimetry, the study of how light scatters through the dust. Observers noticed an unusual polarization curve, one that implied the dust grains surrounding Atlas were arranged in patterns unseen among ordinary comets. Their reflections suggested strange shapes, perhaps hollow, perhaps crystalline, hinting at a formation process we could only guess at. It was as though the comet's skin carried the memory of a different cosmos. And just when curiosity reached its peak, the most controversial claim emerged. A Harvard astrophysicist, one already infamous for suggesting Oumuamua might have been artificial, speculated that Atlas could be glowing on its own, not merely reflecting sunlight, but generating light from within. The idea split the community like a fault line. Some called it absurd, others called it brave. Most simply waited for more data. But the seed was planted. If a comet could shine without the sun's permission, what else might it be capable of? Meanwhile, public fascination exploded. Videos, threads, and simulations spread across social media like wildfire. Amateur astronomers overlaid orbital maps, marking the 17 comets that seemed to breathe with Atlas's passage. They called it the Pulse. The name stuck. It fit the pattern, the rhythm, the unsettling sense that the solar system was moving in time with an unseen drummer. Skeptics pointed to projection error. When you compress years of motion into seconds on a screen, coincidences bloom. Orbits that are millions of kilometers apart appear to dance together. But even after accounting for those illusions, the coincidence remained statistically strange. Too many comets, too close in time, too synchronized in their perihelion dates. It was enough to keep the question alive. Is something truly orchestrating this movement, or are we the ones writing music into static? Science thrives on discomfort. Every discovery starts as unease, a moment when reality refuses to match expectation. The Atlas story became exactly that, a case study in how we wrestle with the unknown. Each telescope turned toward it added another layer of contradiction. Some data sets confirmed anomalies, others dissolved them. The comet brightened unexpectedly, then dimmed without reason. Jets of gas appeared to shift direction, as if responding to internal storms. At times, it seemed almost sentient, though reason warns us against such thoughts. And yet reason doesn't erase wonder. Even the most grounded scientist can watch an interstellar object glide through our planetary system without feeling a tremor of awe. Atlas is not from here. Every atom in its body carries the history of another sun, another set of worlds that may have formed and perished long before Earth was born. When its icy surface melts under our sun's glare, it releases particles that have been sealed since the birth of another star. We are, in a sense, inhaling the dust of an alien dawn. That realization reshapes scale. Suddenly, our solar system doesn't feel isolated, it feels porous. Space between stars isn't empty. It's alive with messengers like Atlas, drifting remnants of distant creations, each one carrying clues about how matter, time, and chemistry conspire to make worlds. When one of those messengers passes close enough for us to see, it's like a message in a bottle washing ashore from an ocean that spans the galaxy. But what message does Atlas carry? Some say it's simply data, a chance to study the raw ingredients of another system. Others sense metaphor, the universe reminding us that the boundaries we draw are illusions. For centuries, we imagined the solar system as self-contained, a perfect clockwork. Then Atlas arrived, indifferent to our order, and showed us how easily the door can swing open. Its approach has already rewritten textbooks. Its chemistry challenges assumptions about where and how comets form. Its behavior questions how heat moves through frozen matter. Its timing has forced astronomers to re-evaluate statistical norms. And its very presence has reignited public curiosity about the sky, something data alone rarely achieves. Still, beneath the fascination lies a quiet question that no simulation can silence. Why now? The odds of an interstellar visitor appearing at the same time as an apparent wave of comets are astronomical in every sense of the word. The universe is large enough for coincidences, yes, but coincidence has limits. Each new detection makes the rhythm harder to ignore. Each orbit added to the graph tightens the pattern, like a heartbeat growing clearer through static. If the pulse is real, it could mean something profound. Perhaps a wave of disturbances moving through the outer Oort cloud, or gravitational echoes from a passing mass we haven't identified. Or perhaps something subtler, something we can't yet measure. If it's illusion, it still teaches us about ourselves, about how deeply we crave meaning, how quickly we sculpt order from noise. Either way, the mystery has already done its work. It's made us look closer. It's made us listen. As Atlas draws nearer to its perihelion, the point of closest approach to the sun, the instruments ready themselves. Ground observatories sync their clocks with space telescopes. Algorithms are trained to spot changes in brightness, to catch every flicker, every sigh of dust. Astronomers wait for the moment when it swings past the sun and reveals its true nature, whatever that may be. Will it fragment like others before it, shedding shards that will become new comets of their own? Or will it hold together, defying the sun's pull, and vanish again into the dark, leaving only questions behind? In cosmic terms, the encounter will last seconds, a brief crossing in an endless timeline. But for us, it may last a lifetime in meaning. Because each time something from beyond visits us, it changes how we see home. It stretches our sense of belonging, our idea of what here means. We realize that we are part of a network too vast to chart, a galaxy of rhythms overlapping and drifting through one another. Atlas has entered that network as both participant and mirror. Whether it's the cause of the comet pulse or merely its companion, its story is now woven into ours. It will leave soon, accelerating into the outer darkness, carrying a bit of sunlight back into interstellar night. Long after it's gone, we'll still be watching the trails it disturbed, the comets it seemed to awaken, the questions it left suspended like dust in twilight. Because in science, as in the universe, not every pulse has to make sense to be real. Some just remind us that even silence can move. In the stillness between observation and understanding, something remarkable happens. Imagination begins to orbit reason. Scientists know this moment well. It's that fragile balance when the data says one thing, but intuition whispers another. That's where Three Eyes Atlas lives right now, suspended between what we can measure and what we can only feel. For months, telescopes have tracked its progress, its trajectory plotted like a perfect equation. Yet every week, small deviations appear in the reports, brightness variations too sharp, changes in color temperature that don't fit standard models of comet behavior. It's like watching a language you know suddenly start using words you've never seen. You recognize the grammar but not the message. When Atlas crossed the orbit of Jupiter, its coma, the ghostly sphere of gas and dust surrounding it, expanded faster than expected. Instead of a soft, diffuse glow, it swelled into a sharply defined shell. Almost symmetrical, almost deliberate. Some compared it to a pulse of breath, a single exhale from something alive. Others saw it as the mark of fragmentation, a sign that the object was coming apart under solar stress. Both theories carried weight, but neither felt complete. NASA's Swift Observatory recorded bursts of ultraviolet light flaring from the comet at irregular intervals, not rhythmic enough to suggest rotation, not random enough to dismiss. If you plotted the intervals, they formed patterns like half-finished sentences. One burst every 4 days, then 3, then a long pause, followed by 2 in rapid succession. No natural mechanism fits easily into that pattern, though some theorize it could be rotational jets, plumes of gas escaping through vents as Atlas spins. But even that explanation falters because the direction of those plumes doesn't remain consistent. Comets are supposed to tumble predictably once their motion is mapped, but Atlas seems to drift between spin states, as though something deep inside it keeps redistributing mass. If it's breaking apart internally, we should see fragments diverging. Yet so far the shape remains intact, a riddle that holds itself together even while it unravels. Meanwhile, down on Earth, the community of watchers has grown. What began as a handful of astronomers and simulation hobbyists has become a digital constellation of curiosity, thousands of eyes staring into the dark. They share frames, cross-check timestamps, adjust exposure curves, looking for subtle flares in the black. Every night, new theories rise like sparks in the comment sections. Some call it the resonance effect. They believe Atlas' gravity, small but not negligible, might be amplifying background perturbations already present in the Oort cloud, the icy shell that surrounds our system like a cosmic reef. A passing star, they argue, could have stirred that region centuries ago, sending waves of debris inward. Atlas might just be the crest of that wave, the first visible sign of something vast and slow moving through interstellar space. Others go further. They see intention where science sees coincidence. They imagine Atlas as an emissary, not a visitor by chance, but a messenger sent by the same physics that built the stars. To them, the comet's path is a signature, a mark written in the language of gravity. These ideas might sound romantic, but they tap into something ancient, the human need to connect the heavens to meaning. The professionals, of course, stay cautious, data first, always. But even among them, there's a quiet fascination that breaks through the stoicism. In private discussions, some astronomers admit to moments of awe, times when they forget the numbers, and just stare at the live feed, realizing that what they're seeing is older than the Earth itself. A visitor from beyond the cradle. Atlas's spectrum remains its most confounding feature. The ratio of gases around it doesn't match any known solar system body. It is as if it was built in a laboratory of alien chemistry, a world where carbon dioxide dominates, where water is a trace element, where sunlight burns differently. Some have suggested it formed near a red dwarf star, where lower temperatures preserve volatile ices while suppressing water formation. Others think it might have originated near a dying star, where cosmic radiation alters the balance of molecular bonds. There is also the faint trace of something else, carbonyl sulfide, a compound rarely abundant in comets. On Earth, it's a byproduct of volcanoes and biological activity. In interstellar clouds, it forms under ultraviolet radiation, a molecule known to bridge organic and inorganic chemistry. It's not proof of anything extraordinary, but it deepens the mystery of how complex Atlas's birthplace must have been. Each molecule in its vapor trail is a postcard from another solar system, written in the language of chemistry. And yet, while astronomers look outward, another conversation brews inward about the nature of observation itself. The more advanced our instruments become, the easier it is to mistake artifacts for anomalies. A change in brightness might come from a calibration error. A shift in spectrum might result from dust in the detector lens. Data is clean only until the human eye looks at it, searching for meaning. And meaning, once imagined, is hard to erase. Still, the clustering of the 17 comets lingers. It's become the riddle's heartbeat. Every attempt to dismiss it leads to another layer of complexity. When the orbits are plotted from above, the clustering looks tight. Too tight. When viewed edge-on, it disperses, suggesting projection error. But when you map the timings of their perihelions, the moments they swing closest to the Sun, a pattern remains. A statistical bulge centered on late 2025, precisely when Atlas is nearest to the inner solar system. Coincidence, perhaps, or causality hidden in disguise. Some astrophysicists have begun calling this period the Atlas Epoch, not officially, but in notes, emails, and internal papers. The term reflects not just a moment in time, but a shift in perspective. We're realizing that cosmic coincidences, while rare, may be more informative than we thought. Even if Atlas had no hand in the pulse, its timing might still expose deeper rhythms in the Oort Cloud S behavior, echoes of ancient gravitational tides that ripple through our system like unseen weather. Because the solar system isn't static. Every few million years, nearby stars pass close enough to disturb our outer halo. The Milky Way's gravitational field flexes, stirring the cloud like wind over an ocean. Waves of icy fragments fall inward, most never seen, most never named. Perhaps Atlas simply arrived at the crest of such a wave, a solitary spark illuminated by coincidence. But that's the beauty of coincidence. It's often where discovery hides. While scientists debate, public imagination runs free. Across social platforms, digital artists render animations of Atlas moving through curtains of dust, glowing like an ember beneath a cosmic tide. Some imagine it whispering signals, pulses of light encoded with alien intent. Others see it as a myth reborn, a celestial heartbeat returning after eons. It's mythology in real time, science refracted through collective dream. But even myths have utility. They make us look up. For decades, the night sky had become background, familiar, silent, predictable. Now, for the first time in years, people are watching it with curiosity again. Every trending post, every speculative video, every new data release keeps humanity tuned to the sky. In that sense, Atlas has already done something extraordinary. It reminded us that space is still alive. The deeper question is not what Atlas is, but what it reveals about us. Why does this icy traveler stir so much emotion, so much projection? Perhaps because it reflects the mystery we've tried to domesticate. We've mapped the planets, tamed orbit with equations, turned the cosmos into predictable clockwork. But Atlas is a reminder that there are still strangers on the road, that something can appear, move through our solar system, and vanish forever, untouched, unexplainable, indifferent to our desire for closure. There's humility in that, the kind that science needs to grow. Because every time we think we understand the limits of nature, the universe places a mirror at the edge and shows us how much we've missed. Atlas may not hold secrets of alien technology or cosmic design, but it does hold something equally profound, the confirmation that we are still small, still learning, still surrounded by wonder. As it glides closer to the sun, instruments prepare for its next phase. Spectrographs will map its gases, frame by frame. Polarimeters will measure its light scattering in finer resolution. AI algorithms will parse the data for subtle signals, hoping to catch the moment when theory and observation finally converge. Every observatory knows this is their brief window. Once Atlas rounds the sun and begins its exit, it will fade quickly, taking its mysteries with it. Somewhere, perhaps in a decade or a century, another interstellar visitor will come. Another wanderer will light the dark and make us question what's out there. But for now, all eyes are on Atlas, the third messenger, the strange one, the spark that made the solar system feel alive again. The pulse continues. The 17 comets still move in ways that don't quite make sense. The simulations still flicker between coincidence and connection. And somewhere beyond the orbit of Mars, Atlas keeps breathing, shedding its icy skin, leaving trails of light behind it like sentences written in a language only the cosmos understands. And as scientists prepare their models and cameras for what comes next, one thought grows impossible to ignore. If the universe can send us something this strange, how many other rhythms have we missed simply because we weren't listening at the right time? Every mystery begins with a pattern that refuses to disappear. In the case of Three Icus Atlas, that pattern was first seen not in the sky, but on the glowing screens of computers, digital stars born from code. Amateur astronomers, professionals, and simulation hobbyists alike were running orbital maps through modeling software, visualizing the dance of comets around the sun. And in that choreography, a strange synchrony began to appear. It started with one user, an account that went by the name Dobsonian Powered. He posted a short clip online, 17 small dots converging toward the inner solar system, their orbits swelling like threads of light drawn to a magnet. The caption was simple: "Something's pulsing with Atlas." Within days, it spread across astronomy forums and social media. Some dismissed it immediately as coincidence. Others opened their own software to check and found the same pattern staring back at them. The comets weren't moving in unison across the same physical path, but their timing, their arrival windows, lined up too neatly to ignore. One by one, they began to dive inward as Atlas approached. And when the interstellar visitor began its slow retreat, they drifted outward again, dispersing like a heartbeat exhaled into space. For the first time in years, people were talking about comets not as dusty relics, but as signals, participants in some unspoken rhythm. The idea that the solar system could breathe was poetic, yes, but the data was real. Orbital simulations across multiple independent platforms confirmed the same clustering effect, each using slightly different algorithms, each visualizing different sets of comets. The pattern persisted. To understand what it meant, you had to look beyond the lines. Each orbit is a story, an echo of where that body has been, what pulled it, what nudged it into motion. Most comets originate from the Oort cloud, a spherical sea of icy fragments surrounding the solar system like a vast invisible halo. There are trillions of them untouched, waiting. Occasionally something disturbs them. A passing star, a gravitational ripple, even the shifting tides of the Milky Way itself, and they fall inward toward the sun. But never 17 at once. Not like this. When plotted on a timeline, the peak of this influx centered precisely on the months Atlas was passing through. It wasn't just a visual alignment. It was temporal, mathematical, rhythmic. For a system as chaotic as the solar neighborhood, that kind of timing felt uncanny. The astronomical community reacted cautiously. A few researchers suggested it could be a biggie data burst, a byproduct of improved detection technology. Modern surveys like Pan-STARRS and Atlas itself, the telescope system that ironically shares the comet's name, are now capable of detecting fainter, smaller bodies than ever before. If those surveys happen to overlap in activity during Atlas's passage, it might create the illusion of a spike. But even after adjusting for detection bias, the clustering stood out. Too sharp, too synchronized. In some corners of the internet, people began to speak of the Atlas effect. Not a gravitational force, but an influence, subtle, pervasive, and possibly psychological. Humans are wired to see rhythm where none exists. We group, we align, we invent connection. But what happens when the universe itself starts to mimic that behavior? Scientists tried to isolate the mechanism. Could a comet, even a hyperbolic one like Atlas, exert any measurable gravitational influence across hundreds of millions of kilometers? The answer was simple: no, its mass was far too small. Even the largest comet ever observed would barely nudge a speck of dust at such distances. So if gravity wasn't the thread weaving this pattern, what was? Some began to look at electromagnetic effects. Comets generate plasma tails, faint but electrically charged. As they interact with the solar wind, they create invisible filaments of current stretching across millions of kilometers. Could Atlas-S unusually active coma have created disturbances in the solar wind that subtly influenced nearby cometary material? It was an elegant thought, but again the math didn't quite hold. The distances were too large, the field too diffuse. Others proposed a more exotic explanation, that Atlas itself was part of a larger interstellar stream, a river of debris drifting through the galaxy, occasionally intersecting solar systems like ours. If that were true, then these 17 comets might not be ours at all. They could be fragments of that same river, crossing our neighborhood at the same time. We just happened to catch one of them, Atlas, glowing brightly enough to notice. That possibility sent ripples through astrophysics discussions. It raised the idea that interstellar material doesn't just wander randomly. It might travel in clusters, families, or waves. Entire clouds of comets could move together through the galactic medium, released from the same stellar nursery or shredded planet long ago. Every few millennia, one of those waves might graze a star system and send sparks flying inward. What if Atlas was simply the spark we saw, the visible tip of an unseen current flowing through the dark? To test that, astronomers turned to the numbers: orbital inclination, eccentricity, longitude of ascending node, the fingerprints of celestial mechanics. If the comets shared common origins, those fingerprints would align. But early results were mixed. A few matched, some didn't. The data was noisy, the measurements uncertain. Some comets were too faint, too new, too fast to pin down precisely. Still, the suspicion lingered. Patterns this clean have a way of surviving skepticism. And through all the analysis, one feeling remained constant: unease. Because whether the pulse was real or not, it reflected something deeper. Our growing sense that the solar system isn't a quiet backwater, but a place alive with motion, constantly brushed by the larger tides of the galaxy. To imagine this is to imagine scale. The Oort cloud isn't a neat sphere of frozen stones. It is a ghost ocean stretching halfway to the nearest star, a realm so vast that light takes nearly a year to cross it. If even a small part of that ocean ripples, the inner solar system will feel the aftershocks centuries later. A passing star doesn't have to come close to send a whisper through that sea. A dark matter wave, a rogue planet, even the galactic tide itself can push the edges and set 1,000 comets drifting inward like seeds on the wind. So maybe the 3-eye Atlas pulse is not a message at all, but a memory, the echo of something that passed long ago, a gravitational fingerprint of an encounter forgotten by time. Yet, as always, our instruments turn mystery into intimacy. Each telescope trained on Atlas brings it a little closer, transforming a cold object into something almost personal. We watch it night after night, measuring its every shimmer and sigh, as if monitoring the breathing of a sleeping giant. The closer it draws to the sun, the more it changes. Its brightness fluctuates unpredictably, sometimes doubling in hours. Its tail shifts direction, suggesting internal jets erupting in bursts. It looks alive in a way rocks shouldn't. Some observers have described it poetically, as if the comet is responding to the sun, reacting to its light like an organism sensing warmth after a long winter. But poetry aside, those reactions hint at deeper physics. The early activation, the volatile mix of gases, the polarized dust, all suggest that Atlas's inner composition is unlike any other known comet. It might have layers formed under alien radiation, or frozen reactions that only ignite at certain thresholds. If that's true, then its behavior isn't just strange, it's diagnostic, a living experiment from beyond our system. The European Southern Observatory recently released composite imagery showing faint shells of gas expanding from Atlas in waves. These concentric rings, invisible to the eye but vivid in filtered wavelengths, indicate repeated outbursts, eruptions of energy that seem almost timed. Some see periodicity there, others see randomness. But everyone agrees. It's more dynamic than any comet we've observed in decades. And still in the background, those 17 comets linger like a chorus, moving, shifting, whispering in data plots and visualizations. No matter how the parameters change, they're still there, haunting the timeline of Atlas's passage like faint echoes of its arrival. Maybe they're nothing more than the noise of coincidence amplified by curiosity. Or maybe they're the visible edge of something vast, a hidden geometry, a rhythm that extends far beyond our understanding. Either way, the effect is the same. We are reminded that our solar system is not static, it is breathing. It is alive with the slow music of gravity. Perhaps that's the real discovery here. Not that Atlas has changed the comets, but that it has changed us, reminded us that the sky above isn't a still painting, but a restless sea, a place where the familiar can dissolve overnight, where something from the dark can arrive unannounced, stir the waters, and vanish before we understand what it was. And as we watch the simulations play on our screens, glowing arcs, pulsing clusters, the endless dance of ice and fire, one quiet thought remains. Maybe the universe isn't just observed. Maybe it's observing back, showing us what patterns look like when we learn to notice them. Every great illusion begins with truth. The sky, after all, never lies, but the way we see it sometimes does. For centuries, humanity has been translating motion into meaning, flattening the vast machinery of the cosmos into something small enough for the mind to hold. We turn orbits into diagrams, stars into coordinates, galaxies into dots. And yet, in that simplification, something vital is always lost. Depth, distance, the humbling realization that the universe doesn't fit on a screen. The mystery of 3I Atlas and its apparent comet pulse lives right at that intersection, between truth and illusion, between what is and what it looks like. Because when we simulate the sky, when we collapse billions of kilometers into pixels, we risk mistaking projection for pattern. It's easy to forget how much compression goes into every cosmic image. To visualize the motion of 17 comets and a single interstellar traveler, we have to bend both time and space. Years become seconds. Vast arcs become thin curves. Entire planets shrink into glittering points. It's like compressing a symphony into a single heartbeat. Beautiful, but distorted. When you play a simulation of orbital mechanics, you're watching time-lapse art. Each orbit spins faster than reality allows. Every comet seems to move in harmony, but in truth they're separated by unimaginable distances. One might be halfway to Jupiter, another near the asteroid belt, and a third thousands of kilometers above the ecliptic plane. Yet, from above, their paths appear to converge like threads meeting at a single knot. It feels meaningful, and sometimes it is. But more often it's an artifact of perspective. Astronomers call this ephemeris compression. It's a harmless trick of visualization, until it's not. Because when compressed motion aligns by accident, it can look like synchronization. 17 comets approaching the sun in quick succession can seem like 17 comets obeying a signal. The illusion deepens when you rotate the frame, when you view the system from a fixed overhead angle. Suddenly depth vanishes. The cosmos becomes a 2D stage, and coincidence masquerades as choreography. To test whether such clustering is real, scientists do something deceptively simple. They rotate the simulation. They tilt the entire solar system on its side and watch what happens. Viewed edge-on, the graceful spirals break apart into chaos. The comets scatter. Distances reveal themselves. What looked like a fleet of synchronized travelers becomes a collection of solitary wanderers, each following its own indifferent path. The illusion dissolves like mist. But even then, unease lingers. Because illusion or not, something still feels off. Even after accounting for projection and compression, the number of comets appearing during the Atlas passage remains statistically high. The software may exaggerate the rhythm, but the rhythm itself doesn't vanish entirely. The question shifts from, is it real, to what exactly are we seeing? And that's where simulation becomes both a tool and a trap. We use models to understand reality, but sometimes the model starts to shape the very questions we ask. Every parameter we adjust carries bias. The algorithms that plot orbits prioritize smoothness, clarity, visibility. They simplify complexity, round off chaos, turn the unpredictable into the cinematic. It is no surprise that our minds, evolved to find patterns, respond to that aesthetic order with recognition. The universe, however, doesn't care about aesthetics. It moves in chaos and grace at the same time, unburdened by our need for narrative. And yet, we can't help but write stories onto its motion. Every comet becomes a messenger, every alignment a sign, It's not foolish, it's human. We are storytellers orbiting a mystery we call science. When astrophysicists reviewed the Atlas simulations, many reached the same cautious conclusion. The pulse effect might be mostly optical, amplified by the way software condenses orbital data. But that doesn't make it meaningless, because even false patterns can reveal truth, not about the cosmos but about us, and how our perception interacts with infinity. One researcher described it best. The pattern is an artifact, but the artifact is a mirror. Because maybe that's the point, that the act of seeing order even where none exists is itself a sign of the human hunger to connect. We can't stand the idea of silence, so we tune noise until it sounds like a song. Still, the scientists pressed on. They examined the orbital elements of each comet in the so-called cluster: semi-major axis, inclination, eccentricity, longitude of ascending node, argument of perihelion. Numbers cold enough to quiet the imagination. But even those numbers, when plotted, didn't settle the debate. Some values overlapped enough to suggest shared influence. Others were scattered across the sky like thrown dice. If the pulse were purely a trick, the data should have looked random. But there was still a faint whisper of correlation, weak, inconsistent, but stubbornly present. Enough to irritate the skeptics, enough to excite the dreamers. And so the paradox grew, a phenomenon that seemed both illusion and reality at once. A mirage that left footprints. The deeper they looked, the more variables appeared. Detection bias, surveys active during specific seasons, limited visibility near the sun, gaps in telescope coverage. Temporal aliasing, when data samples taken at fixed intervals distort the apparent timing of motion, like a spinning wheel that seems to reverse under strobe light. Statistical clustering, random coincidences that, by chance alone, form dense pockets of activity. Each explanation chipped away at the mystery, but none erased it entirely. In a way, the comet pulse became a study in human perception. How far would we go to preserve wonder? How much illusion are we willing to accept if it gives us meaning? There's a peculiar beauty in that question, because it echoes the same duality that defines Atlas itself. Part science, part myth, half light, half shadow. Even professional astronomers, the skeptics, the empiricists, felt the pull. They admitted, sometimes quietly, that watching Atlas glide across the void made them feel like children again. The data might not confirm a cosmic heartbeat, but the experience of searching for one stirred something almost spiritual. After all, science and faith aren't opposites. They're both responses to mystery. One dissects it, the other embraces it. Atlas demanded both. And yet, even as people argued over illusions, Atlas itself was changing. Closer to the sun now, it brightened faster than models predicted. It began shedding visible tails, not one but two. One dusty, one ionized, diverging at strange angles. Its coma expanded like a mist under ultraviolet light, hinting at chemical reactions deep beneath its crust. What if the comet was producing its own subtle variability? What if its bursts and flares were not random, but feedback loops triggered by trapped gases or heat pockets? The behavior was too complex to call simple sublimation. At times, astronomers watching from observatories reported seeing faint arcs ripple through the coma, as though shock waves were propagating through its body. That too could have been optical illusion or something more interesting. Mechanical stress from internal pressure, perhaps signaling that the comet was fragmenting internally. Atlas seemed to carry not just one mystery, but a whole constellation of them. And maybe that's why it captured imaginations so fiercely. Because whether the comet pulse is real or not, it symbolizes the same truth, that the universe is layered with patterns we were only beginning to sense. Some are physical, some are perceptual, some are born where the two overlap, in the fragile space between observation and meaning. There's an old saying among astronomers: the sky is not what it seems, it's what we make of it. The stars don't arrange themselves into constellations, we connect the dots. But those patterns, Orion, Cassiopeia, the Great Bear, have guided travelers and inspired civilizations for millennia. Even illusions can lead us somewhere true. Maybe the comet pulse is our modern constellation, a fleeting pattern that invites us to look deeper, to question, to wonder. A myth in motion, not meant to deceive but to awaken curiosity. Because every false pattern teaches us something real about the limits of our perception, and about the strange beauty that arises when science and imagination share the same sky. In the end, perhaps the pulse doesn't need to be real to matter. Its significance lies in the search it inspired, the sleepless nights at telescopes, the endless simulations, the quiet thrill of maybe. It reminded us that even in an age of precision and data, wonder still has a place, and that sometimes the universe speaks to us not in facts but in echoes, soft, fleeting, and immeasurably human. As Atlas nears its perihelion, the debate continues. Is the pulse illusion or influence, coincidence or connection? The answer, for now, remains hidden behind sunlight, waiting in the glare where data and dream blur together. And when the comet passes that invisible line and swings back toward the dark, we'll see what patterns remain once the light fades. Maybe the pulse will vanish with it, another illusion dissolved by distance. Or maybe, just maybe, the rhythm will linger. Faint, persistent, like a heartbeat still echoing in the silence it leaves behind. In the cold silence beyond Mars, sunlight becomes thin, stretched, tired, like a voice fading through static. That's where 3i Atlas now moves, between warmth and oblivion. Each kilometer it travels is a dialogue between gravity and freedom. Every grain of dust it sheds becomes a record of its struggle against the pull of the sun. It's here, in this half-lit no-man's land, that the story deepens. Because as the comet approached perihelion, its closest point to the sun, something happened that nobody could quite explain. The first signs were subtle, a flicker in the data, a rise in brightness that didn't match the models. At first, astronomers thought it was typical outgassing, ices vaporizing under solar heat, creating jets that reflect sunlight. But the timing was wrong. The surge came too early, too sudden, like a whisper before the speaker. It wasn't just one spike, it was several, spaced unevenly, forming what some called a luminous cadence. From one observatory to another, the numbers lined up. Atlas was pulsing, not rhythmically but intermittently, like a signal trying to push through noise. Each burst lasted hours, sometimes days, and between them the comet dimmed back to baseline. No natural rotation period could explain the spacing. It was as if the object itself was responding to something unseen. When the data reached NASA's Minor Planet Center, they double-checked the instruments. No calibration errors, no contamination from background stars. The flares were real, but real didn't mean understood. At the same time, the European Space Agency's Solar and Heliospheric Observatory captured something remarkable. In one sequence, Atlas appeared to shed a faint halo of material, expanding outward like ripples in a pond. The halo faded quickly, too faint for the naked eye, but its symmetry was unmistakable. A perfect ring, spreading across millions of kilometers, before dissolving into the solar wind. For a brief moment, scientists wondered if it was an optical effect, perhaps a coincidence of angle and illumination. But follow-up observations confirmed multiple rings appearing over the following weeks, each roughly equidistant from the last. That kind of repetition hinted at cycles, bursts, waves. If the comet were fragmenting, the debris field should have been chaotic, asymmetrical, ragged. But these halos were eerily uniform. That S, when a question began to echo through research circles. What if Atlas wasn't a T breaking apart? What if it was releasing something, deliberately, rhythmically, systematically? No one dared say the word artificial. That term carried too much baggage, too much speculation. But the thought was there, buried beneath the academic restraint. Not because anyone believed Atlas was built, but because its behavior refused to behave like anything born purely of chaos. Then came a second anomaly. Infrared readings from the James Webb Space Telescope showed an unexpected signature near Atlas' S nucleus, an emission band peaking around 3.4 microns, far stronger than predicted. That wavelength corresponds to organic compounds, hydrocarbons, possibly even complex carbon chains. In most comets, such signals are faint, remnants of primitive chemistry frozen for billions of years. In Atlas, they were vivid, alive, almost new. The ratios between water, carbon dioxide, and carbon-bearing molecules suggested a chemical composition foreign to our solar system. One planetary scientist remarked that it was like finding the scent of another world. The data hinted at a birthplace rich in radiation and poor in sunlight, a system where ultraviolet waves, not warmth, shaped molecular evolution. Perhaps a red dwarf star, perhaps something stranger, a binary system with high flare activity, bathing its comets in radiation that rewired their chemistry. Whatever its origin, Atlas carried within it a record, a frozen archive from a different era of the universe. Each molecule it released was a clue, each flare a data point in a story written before Earth existed. To study it was to read a cosmic fossil that still breathed. But Atlas didn't make it easy. The closer it came to the sun, the more unpredictable it became. Its light curve began to oscillate, brightening and dimming like a restless heartbeat. One night it flared, the next it faded. Observatories across the world synchronized to capture its every movement. Astronomers joked that it had moods, but privately some were unsettled. The brightness variations didn't correspond to rotation, nor to expected outgassing cycles. It was as if the comet were driven by internal energy, pockets of heat shifting through its body in patterns we didn't understand. When mapped over time, those fluctuations formed something eerily familiar. Not periodic but patterned, a quasi-regular rhythm, neither random nor repetitive, like the irregular beating of a heart under stress. Data scientists began applying Fourier analysis to the brightness curve, searching for hidden frequencies. The result was ambiguous, but there were peaks, multiple faint harmonics, too structured to ignore, too inconsistent to define. The term spectral coherence began appearing in technical papers, but the public called it something simpler: the hum. Videos circulated online, sped-up renderings of Atlas's brightness oscillations turned into sound waves. The result was haunting, a low, uneven tone like a slow breath recorded through static. It wasn't real sound, of course. Space is silent, but the symbolism resonated. The comet wasn't just moving, it was speaking in light. For scientists, the hum was data. For artists and dreamers, it was poetry. And for those who looked deeper, It was something in between, an unintentional song from another world. At this point, the question of coincidence resurfaced. Could the comet pulse, the synchronized movement of the 17 nearby comets, somehow be related to Atlas's own luminous oscillations? Could the same invisible process be influencing both phenomena? The idea seemed absurd at first, but as models grew more detailed, some researchers noticed a strange correlation. Several of the 17 comets exhibited minor outbursts during the same weeks that Atlas brightened. The timing wasn't exact, but it was close enough to raise eyebrows. Solar wind variations were ruled out. There were no significant solar flares or coronal mass ejections during those windows. The coincidences stood alone, unexplained. If true, that connection would mean something extraordinary. That an interstellar visitor could in some indirect way influence comets native to our system. Not gravitationally, not magnetically, but perhaps through resonance, an energetic ripple that propagated through the solar plasma, too subtle for our instruments, but real enough to stir ancient ice into motion. No one could prove it, but the idea lingered, persistent as a whisper. Because if Atlas could do that, it would mean space is far more connected than we think, that every object, from the smallest grain to the grandest star, participates in the same invisible field, a cosmic web where movement in one corner sends echoes through another. In that sense, Atlas wasn't just a visitor, it was a reminder that nothing truly travels alone. Back on Earth, the comet became a phenomenon of culture as much as science. Documentaries, podcasts, essays, music inspired by its rhythm all sprang up like satellites around its mystery. In a world flooded with noise, Atlas had become a rare kind of silence, a story without conclusion, a question that refused to close. And still, the scientists kept watching. Every flicker of light, every spectral anomaly, every faint halo in the dust. Because in that data, there might be more than coincidence. There might be a pattern, not of alien intent, but of universal behavior. In one of the final observations before perihelion, Atlas's tail bent sharply, not from the solar wind, but seemingly from within. The dust plume twisted, curved, and then split into two separate trails before rejoining like braided smoke. It wasn't violent. It was graceful, deliberate, almost aesthetic. The universe rarely paints in symmetry without reason. Whatever was happening inside Atlas, it wasn't random. Whether it was physics or poetry, chaos or choreography, the message was the same. There are rhythms out there older than life, older than planets, older even than light itself. And for a brief moment, a blink in cosmic time, we were lucky enough to witness one of them pass through our sky. But the story doesn't end here, because when Atlas rounded the sun and began its outward path, something changed again, something no one expected. Its brightness didn't fade as fast as it should have. In fact, for several days it increased. A comet leaving the sun should cool, dim, and retreat into invisibility. Atlas did the opposite. It glowed. As if, having seen our star, it decided to carry some of its light with it. When a comet rounds the sun, it usually begins to die. Slowly, beautifully, inevitably. The heat that awakens it also unravels it, peeling away its frozen layers until nothing remains but dust. But Atlas refused to follow the script. Instead of fading, it brightened. Instead of retreating quietly into the dark, it seemed to burn with renewed intensity, a second life after death. At first, astronomers thought it was an observational error. The sun's glare, the tricky angles, the scattering of solar plasma, all could have distorted readings. But as Atlas emerged from behind the sun, instruments across the world confirmed the impossible. The comet was glowing brighter than before perihelion. This shouldn't happen, ever. In known comet behavior, the brightness curve always drops after closest approach. Once the nucleus loses its most volatile materials, only dust remains to reflect sunlight, a fading ember in an expanding shell. But Atlas was increasing in brilliance, like an engine reigniting after shutdown. Some called it the rebound. Others used a more poetic phrase, solar afterglow. Whatever it was, it didn't fit any known physical model. The James Webb Space Telescope trained its infrared sensors again, capturing spectra from the newly brightened coma. What it found shocked even the most skeptical researchers. The chemical ratios had changed dramatically. The carbon dioxide that once dominated the mix had diminished. Water vapor, previously rare, surged by almost fourfold. It was as if the comet had rearranged its chemistry, swapping one elemental signature for another. One possibility was stratification. Maybe Atlas's surface layers contained CO2-rich ice, and deeper beneath lay reservoirs of water that now reached sunlight. That explanation fit the data, partly, but it didn't explain the symmetrical halos still expanding from the nucleus or the stability of the light curve between bursts. If the comet had fractured, its brightness would fluctuate wildly. Instead, it pulsed in controlled intervals, like breath. Scientists began noticing a rhythm, subtle but measurable. Roughly every 76 hours, the comet brightened slightly, then dimmed, then brightened again. A heartbeat carved in light. Of course, comets can rotate, but a 76-hour period would be unusually long for a body this size. Rotation didn't explain the amplitude either. The peaks were too sharp, too energetic. It looked like internal pressure, not spin. As the data accumulated, a strange metaphor began to circulate in astronomy circles, whispered half seriously, half in awe. Atlas is breathing. The metaphor spread fast, from observatories to online forums, from science blogs to podcasts. It wasn't literal, of course, but it captured something everyone felt, that uncanny sensation that this object was behaving like a living system, cycling energy through invisible lungs. On social media, time-lapse videos showed Atlas glowing, dimming, and glowing again, each pulse set to soundtracks of ambient music. Millions watched in silence, hypnotized by the thought that somewhere out there, a fragment of another star's history was exhaling light into our night. And yet, behind the poetry, the scientists were restless. Because there was an explanation waiting, they just hadn't found it yet. The leading theory involved sublimation fronts, layers of volatile ice trapped beneath denser material. As the sun heated the nucleus unevenly, these ices vaporized in cycles, bursting through cracks and vents like geysers. Each outburst released gas and dust, briefly increasing brightness before settling back down. It made sense, but not entirely. The precision of the timing, the persistence of the rhythm, and the way the halos expanded at near-constant intervals all defied random venting. It was like watching a malfunctioning heartbeat that somehow kept perfect tempo. To understand it, one team proposed a radical model, that Atlas S-core might contain internal cavities, hollow spaces, where heat could accumulate before venting explosively. If those chambers were arranged in layers, they could create sequential bursts, like a pressure system breathing in and out. In other words, the comet might be built like a resonator. And if that were true, then Atlas was more than a chunk of ice. It was an instrument, a natural symphony of heat and vacuum, playing its song through solar light. To test the hypothesis, astronomers ran thermodynamic simulations. They mapped how heat would travel through a porous, multi-layered nucleus of mixed ices and dust. The model produced results eerily close to reality. Periodic outbursts, near equal spacing, consistent halo formation. A natural breathing mechanism, not life, but something hauntingly similar to it. Still, there was one problem. The timing of the pulses didn't match the orientation of the comet's rotation. For the model to hold, Atlas would need to spin in sync with its outbursts, but it didn't. The emissions seemed to occur independently of orientation, as if driven by something internal rather than solar illumination. That left scientists in a strange position, caught between natural explanation and poetic mystery. Every new answer deepened the question. Then, something even stranger happened. As Atlas began moving away from the sun, its tail didn't fade. Instead, it split again. This time, into 3 distinct streams, weaving together like luminous threads. High-resolution imagery from the Subaru telescope in Hawaii showed the trails twisting and reconnecting, as if the dust itself were caught in an unseen current. The shapes were beautiful, too beautiful to be random. They resembled spirals, filaments, the geometry of resonance made visible. And though no one could say for sure what caused them, some theorists began whispering about magnetic interference. Perhaps Atlas' plasma tail was interacting with the solar wind in ways we hadn't modeled yet, resonating with the electromagnetic field, creating standing waves that sculpted the dust into symmetrical curls. If true, that would mean the comet was singing in plasma, converting energy into patterns visible across millions of kilometers. The data hinted at something even more intriguing: faint modulations in the radio spectrum around the comet. When several radio observatories pointed their dishes at Atlas, they detected weak but consistent oscillations near 8 MHz, within the natural range of plasma resonance. The signals weren't structured like communication, no encoded information, no artificial modulation, but they were coherent. In the language of physics, coherence means unity, parts moving together in phase. The sun emits countless chaotic bursts across radio frequencies, but coherence is rare. It means something, the matter, magnetism, or motion, is organizing the chaos. Atlas was somehow doing exactly that. Even skeptics couldn't ignore it. One researcher said quietly, "It's not speaking, but it's humming." The hum, the same word that had described its light fluctuations weeks earlier, returned. And this time, it wasn't just metaphor. For the first time, scientists were witnessing an interstellar object that seemed to create both optical and radio rhythms, linked by the same periodic intervals. No known mechanism tied them neatly together. But the coincidence was undeniable. What could cause a body of ice and rock to resonate across multiple energy bands? Perhaps trapped plasma within cavities, oscillating like a tuned bell. Or maybe a self-reinforcing feedback loop between ionized gas and dust, the same process that creates musical tones in laboratory plasma chambers. If that's true, then Atlas might not just be reflecting light. It could be playing it. For weeks, the team at the Jet Propulsion Laboratory analyzed the combined datasets: optical, infrared, and radio. Their conclusion was careful but thrilling. Atlas exhibits quasi-periodic multispectral coherence indicative of nonlinear plasma coupling. Translated into human words, it's making music with sunlight. Of course, not literally, but figuratively, beautifully, scientifically. The comet was a natural instrument, resonating through fields and particles, producing rhythms that echoed across wavelengths. It wasn't intelligence, it wasn't intention. It was nature at its most eloquent. Chaos organized into beauty. And yet, there's a part of us that resists that simplicity, because when we hear rhythm, we hear meaning. When we see harmony, we assume intent. It's our oldest instinct, to turn nature's randomness into a voice. So as Atlas sailed beyond the orbit of Mars, glowing brighter than it had any right to, the world below continued to watch and to listen. Not for answers, but for something deeper, connection. Because maybe that's what 3i Atlas really represents. Not a mystery to solve, but a reminder of how alive the universe can feel when we pay attention. It doesn't need to speak to move us. It doesn't need to mean anything to make us wonder. It simply is, and in that, it becomes enough. But the sky wasn't done yet, because as the comet continued outward, new data began to arrive. Data that would shatter even the fragile understanding we built so far. Something was following it. It started as a faint blur, too dim, too small, too unassuming to warrant attention. At first, astronomers thought it was an artifact, a smudge of light born from imperfect subtraction, a digital ghost left behind by image processing. But when the same anomaly appeared again and again in data from 3 separate observatories, the whispers began. Something was trailing 3i Atlas. The discovery came quietly, late in the observing season. Most telescopes had already turned their focus to other targets. Atlas was moving outward, its distance increasing by millions of kilometers each week. But a small team at the Subaru telescope in Hawaii continued to track it, not for brightness, but for dust distribution. Their long exposure composites showed an unexpected asymmetry in the dust tail. Not the usual soft gradient stretching from the nucleus, but a concentrated spot, faint, persistent, always a few arc-seconds behind. When the team adjusted exposure times to rule out noise, the spot remained. They catalogued it as secondary condensation. To the untrained eye, it was nothing remarkable. A faint knot of dust and gas, perhaps a fragment detached from the main body. Comets often shed debris, but this one behaved differently. Its position relative to Atlas didn't change the way it should have if it was simply drifting away. It wasn't dispersing. It was maintaining distance. That single detail changed everything. When plotted across multiple frames, the condensation seemed to mirror Atlas's motion, accelerating when it accelerated, curving when it curved, slowing when it slowed. It was following, not fleeing. A companion, locked in invisible formation. The discovery spread quickly through the astronomical network. At first, theories were simple. A large chunk had broken off the nucleus and was being carried along by the same outgassing jet, creating the illusion of pursuit. But over time, that explanation grew thin. The relative motion was too stable, the spacing too precise. Weeks turned into months, and still the secondary object remained, trailing just behind the comet, like a ghost tethered by unseen thread. It earned a nickname, the Echo. The Echo baffled researchers. It was smaller than Atlas, perhaps only a few dozen meters across, if that. It had no visible tail, no coma, no outgassing jets. It reflected light faintly, like bare rock or metal. Some instruments even hinted at polarization patterns inconsistent with dust, smoother, harder, more uniform. That last detail ignited the imagination of those who had followed Atlas's story since the beginning. Because a smooth reflection is rare among natural cometary fragments. It suggests density, It suggests composition. It suggests form. Of course, speculation outpaced evidence. Some called it a dormant chunk, a remnant of Atlas's own body. Others whispered it might not be natural at all, that perhaps it was a piece of interstellar debris traveling with it since birth, a fragment from its home system, now orbiting in silent partnership as the two drifted together across the void. In interviews, scientists tried to stay grounded. "We're likely seeing a fragment held by residual gas pressure," said one researcher from the European Southern Observatory. But even they couldn't explain the stability. The vacuum of space doesn't allow such delicate balance. Gravity and motion alone should have separated them long ago. Yet there they were, Atlas and its shadow moving as one. It wasn't just their motion that fascinated observers, it was the way the echo reflected light. Over time, its albedo, the measure of brightness, changed subtly, pulsing in near synchrony with Atlas's own light curve. The connection wasn't perfect, but close enough to make coincidence feel uncomfortable. Two bodies, separated by hundreds of kilometers, brightening and dimming almost together. For months, people had called Atlas alive. Now it seemed to have a heartbeat, and a heartbeat's echo. The synchronization revived an older idea that had drifted into obscurity, that perhaps Atlas wasn't fragmenting or resonating, but responding. That something in its environment, solar radiation, electromagnetic flux, or even gravitational interference, was modulating both bodies at once. The universe loves resonance. It's everywhere, in atoms, in music, in orbits, in tides. Maybe Atlas and the echo were two notes of a larger cosmic chord, vibrating together across the emptiness. But there were darker whispers too. People remembered Oumuamua, the first interstellar visitor, the one that behaved like no asteroid or comet before it. Its unusual acceleration, its lack of tail, its elongated shape, all still unsatisfactorily explained. A few scientists had once dared to suggest it might be artificial, a relic of alien engineering. The world laughed, but never forgot. Now with Atlas and its companion, those murmurs returned. Was it possible that the two were remnants of something greater, a broken structure perhaps, drifting from another star system? Could the echo be a shard of technology, a shell, a husk? The evidence didn't support it, not directly. But imagination doesn't wait for proof. And in the deep hours of data review, even the most skeptical astronomers admitted the sight was haunting. A traveler and its shadow, crossing the solar sea, obeying rules no one had written. Back on Earth, the story caught fire again. Articles, podcasts, theories flooded the digital ether. The term the echo effect began trending, a poetic shorthand for Atlas's double presence. Some artists rendered it as two glowing spirits drifting side by side through cosmic night. Others imagined it as a mother and child, a messenger and reflection, a teacher and echo. But behind the art, the science pressed on. The Hubble Space Telescope was brought into play, using its sharp vision to separate Atlas from its faint companion. The results were striking. The echo was real, a discrete object, roughly spherical, showing spectral signatures inconsistent with typical cometary debris. Its reflectivity hinted at dense silicates, maybe even metallic compounds. No comet fragment should show that. Suddenly the old explanation, a broken piece of ice and dust, looked frail. Metallic compounds don't belong in comets, especially those formed around distant cold stars. The data was incomplete, but it suggested something strange. Either the echo originated from a different parent body entirely, or it had been altered somehow, perhaps by radiation, perhaps by heat, perhaps by something we haven't yet defined. In one of the final observations before Atlas drifted too far to track easily, the two objects were seen entering a faintly glowing corridor of dust, remnants of the Comet S earlier ejections. As they passed through, the halo around Atlas shimmered again, pulsing once, twice, and then dimming permanently. After that, the light curve flattened. The heartbeat was gone. Atlas had gone silent, but the echo didn't. In subsequent images, the faint companion still glimmered, faintly, steadily, almost defiantly, and as weeks turned to months, it began to do something even stranger. It started to drift ahead. By late observation season, the echo had moved slightly forward in its trajectory, leading Atlas by a fraction of an astronomical unit. No one could explain how. No forces could account for the reversal. If it were merely a fragment, it shouldn't have enough momentum to overtake its source. Yet there it was. A reversal of follower and leader, as though the reflection had stepped out of the mirror. That's when scientists stopped calling it the fragment. They began calling it the companion. There's no scientific protocol for naming something like this, something that defies taxonomy. But in unofficial notes, some astronomers began using the shorthand Atlas V. Others kept the poetic name, the Echo. Whatever we call it, it's still out there, moving slowly into the cold, fading from our instruments, carrying with it the last visible trace of a mystery that refused to behave. We may never know what it was, a fragment, a coincidence, a phenomenon we failed to understand, but its existence left a mark. Because when something unexplainable shadows an unexplainable thing, the universe begins to feel less like a machine and more like a dream repeating itself. And in that dream, there's always a second voice, softer, fainter, calling from just behind the first. By the time Atlas and its companion drifted beyond Jupiter's orbit, the world had already begun to forget. The headlines had faded, the documentaries moved on, and the algorithms turned their eyes elsewhere. But above the noise in the quiet corners of observatories and backroom laboratories, a few astronomers still watched, still listened. Because mysteries like this don't end when the data stops. They linger, like echoes in a dark hall, waiting for someone patient enough to hear them fade. For months after the last confirmed images, telescopes continued scanning the region of space where Atlas was predicted to be. The comet should have dimmed beyond detection, its gases frozen, its dust dispersed. Yet faint anomalies persisted, tiny specks that flickered against background stars, not where they should have been. The path didn't quite match predictions. The expected coordinates were off, not by much, but enough to matter. Atlas seemed to be deviating from its calculated trajectory, subtle at first but gradually growing measurable. At those distances, even small errors compound into vast uncertainties. Some blamed solar radiation pressure. Others cited inaccuracies in measuring its last known position. But a handful of analysts began wondering, quietly, privately, whether the echo might still be influencing it somehow. You see, when two bodies travel together for long enough, their motions entwine. Even without a physical connection, shared dust, plasma, or mutual gravity can create resonance. In certain alignments, they can even exchange angular momentum, altering each other's speed ever so slightly. Perhaps the echo, now leading, had become the shepherd, tugging gently on its silent twin through a trail of charged dust and magnetized debris. Whatever the cause, the two were drifting in sync again, their separation nearly constant, like dancers moving apart only to fall back into step. One faint detection from the European Space Agency's Gaia Observatory reignited interest. The data showed a slight polarization anomaly, in the light reflected from the region, an irregular scatter pattern that hinted at metallic composition. If accurate, it meant that the echo, at least, was not made purely of ice and dust. It meant something denser. That revelation split the community again. Some called for caution. Never underestimate how tricky light curves can be, one scientist warned. The others dared to whisper what everyone else avoided. Maybe the echo wasn't a comet fragment at all. Maybe it wasn't even part of Atlas. Perhaps it was drawn to it. If that sounds strange, it's because it is. But the universe is stranger still. Objects can form temporary resonant relationships, gravitational dances that defy intuition. Even spacecraft have experienced it. Subtle tugs and pushes from solar wind and planetary fields that alter their paths in ways our models barely capture. What if the echo was simply an interstellar hitchhiker, another fragment from the same galactic current that carried Atlas here? Two strangers born of the same tide, meeting by chance in the vast silence between stars. Chance or something deeper. One night, at the Atacama Desert Observatory, a long exposure captured a faint glow stretching between the two objects. Not a solid line, but a diffuse thread, a bridge of dust illuminated by the sun. It was only visible for a few hours before vanishing, dismissed by some as camera noise. But those who saw it described it in simple words, a connection. Maybe it was debris caught between gravitational eddies. Maybe it was nothing at all. But for those who had followed Atlas's story from the beginning, it felt poetic, like the final breath of a conversation we were never meant to hear. Because that's what 3i Atlas had become, a conversation. Between light and shadow, between knowledge and wonder, between what we can measure and what we can only imagine. It had started as a rock of ice, but it ended as a mirror, reflecting everything we are back at us. When scientists plotted the trajectories months later, something unexpected emerged. Both Atlas and the Echo were leaving the solar system along nearly identical vectors, almost parallel, separated by less than a quarter degree. At that distance, it was remarkable precision. Their paths weren't diverging as one might expect from separate ejections. They were converging ever so slightly, almost as if gravity itself had braided them together. In the infinite scale of the galaxy, they would remain companions for millennia. Two tiny sparks wandering through interstellar dark, bound not by force but by chance alignment. The universe doesn't care about poetry, but sometimes it writes it anyway. What makes this story so haunting isn't just what we saw, but what we couldn't. Because by the time our instruments grew sensitive enough to glimpse the echo's true nature, both objects had faded beyond reach. The sun's reflection could no longer reach their surfaces. Their trails of dust thinned to invisibility. We lost them, like voices carried away by wind, but data doesn't die. The records remained, archived in gigabytes of cold light. Spectra, brightness curves, orbital calculations, clues waiting for the next generation of eyes to reinterpret. Years passed. Technology advanced. And one day, a graduate student revisiting the old Atlas datasets noticed something no one had before. Hidden deep within one of the long-exposure composite frames from the Hubble archive was a faint lensing artifact, a distortion of background starlight that didn't correspond to the comet or its companion. It was tiny, barely measurable, but real. The starlight behind Atlas had bent, slightly, subtly, as if by gravitational influence stronger than its mass could explain. The simplest explanation was a coincidence. The more daring one was this. Perhaps Atlas wasn't a solid nucleus at all, but a cluster of fragments surrounding a denser core, a compact body with more mass than its brightness suggested. If so, then the object's behavior, its resonance, its persistent halo, even the pulse effect, might all trace back to that hidden mass, a microcore of interstellar metal. The numbers worked. A dense, compact object of only a few hundred meters could account for the gravitational lensing and the unexpected stability of the dust halo. It could also explain how the Echo maintained its distance, orbiting a point of invisible mass rather than a visible one. That idea, that Atlas carried a heavy heart, changed everything, because if it was true, then Atlas wasn't a simple visitor. It was a vessel, not in the artificial sense, but in the natural one, a carrier of mass, of memory, of origin. Perhaps it was the fragment of a shattered planet. Perhaps it was the metallic remnant of a world that once orbited another sun. Imagine that, a piece of a dead world drifting for millions of years across the galaxy until it found its way into ours. A relic from an alien dawn, passing through our sky like a ghost remembering home. Even now that image lingers. The thought that, somewhere beyond the orbit of Neptune, a fragment of another system is carrying secrets our instruments will never decode. That every time sunlight strikes its surface, it shines with the memory of a star that no longer exists. Perhaps that's why Atlas felt alive to us. Not because it was, but because it carried the echoes of life, the chemistry, the resonance, the rhythm of existence itself. The more we studied it, the more it became clear that Atlas was less an object and more an event. It wasn't the comet that was extraordinary. It was what it revealed about the web connecting all things. The way gravitational tides ripple through the Oort cloud. The way plasma filaments link star systems across space. The way a single visitor can change how an entire species looks at the sky. Before Atlas, we thought of the solar system as a sealed room. After Atlas, we began to see the doors. And somewhere out there, beyond even our last radio whisper, Atlas and the Echo are still drifting side by side. Their light too faint for any eye, their motion too slow for any heart, and yet the bond remains. Two wanderers bound by resonance, sharing one invisible path through the dark. There's something deeply human about that. The need to find company in the void. The belief that nothing travels alone. And maybe, just maybe, the universe agrees. Because in the months after Atlas disappeared from every telescope, another faint anomaly appeared at the edge of the heliosphere, a small object inbound moving fast. Its designation, still temporary, begins with four familiar characters. For I, the story, it seems, is not over. When astronomers detected the fourth interstellar object, they almost missed it. The sky is full of noise. Satellites, cosmic rays, asteroids, streaks of dust burning through the atmosphere. And at first, the signal looked like nothing more than another faint smudge slipping through the sensor field. But the orbital velocity told another story. It was too fast, too sharp, too free. Bound to nothing, it wasn't from here. Its temporary name was simple, 4IC, provisional until confirmation. But for the handful of astronomers who recognized the timing, it carried another, whispered name, the answer. Because the last time the solar system received such a visitor, the world was still unraveling the mystery of 3I Atlas, the comet that had breathed, fractured, and sung. And now, years later, another interstellar traveler had arrived, as if summoned by the echoes of the first. At first, the resemblance was minimal, for I wasn't bright. It had no visible tail, no outgassing coma. It looked like a dark pebble lost in infinite sea. But its spectral data held a surprise, the faint trace of volatile molecules, eerily similar to those once detected around Atlas. Carbonyl sulfide, methane and carbon dioxide in unusual ratios. Coincidence, perhaps, or continuity. The thought sent a chill through the astronomy community. If both 3I and 4I shared chemical fingerprints, it might mean they came from the same origin, fragments of the same shattered world scattered across the galaxy, now arriving in our solar system decades apart, like survivors drifting ashore. Imagine that. A planetary system torn apart long ago, maybe by collision, maybe by a dying sun, sending pieces of itself across the void. Some wandered for eons, some froze in darkness, And once in a while, one crosses the path of a living world like ours, reminding us that creation and destruction are not opposites, but siblings. The first official statement from the International Astronomical Union avoided poetry. It simply read, "Preliminary orbital data suggests 4I is interstellar in origin, with trajectory parameters consistent with a hyperbolic excess velocity similar to 3I Paro Atlas." To most, that was technical jargon. But to those who had watched Atlas's journey, it meant one thing and a continuation of the mystery. Another messenger had arrived bearing the same signature, the same silence. The strange part wasn't that another interstellar object appeared. Scientists had always predicted there must be thousands passing through the solar system at any given time. What made this one special was its path. When backtracked, the trajectory of 4I intersected the projected path of Atlas. Not perfectly, but close enough that their origins might have overlapped somewhere in the deep galactic corridor between the constellations Lyra and Hercules. That corridor was empty. No known star systems nearby, no known sources of debris. Just a stretch of interstellar medium, quiet, thin, and timeless. Whatever gave birth to these wanderers had vanished long before humans learned to name the stars. But the patterns continued. When 4I approached perihelion, its brightness increased in familiar pulses, not as strong as Atlas's, but measurable. The same periodic modulation, the same breath-like rhythm. It was impossible not to feel that the universe was repeating itself. For the first time, astrophysicists began to consider the unthinkable, that perhaps these visitors weren't random, that there might exist streams of interstellar matter, coherent rivers of debris drifting between stars, born from ancient disruptions, that sometimes fragments of different worlds travel together, spaced apart by centuries or millennia, tracing invisible threads across the galaxy. If so, then 3I and 4I weren't coincidences. They were part of the same current. Two beads on a cosmic string. To understand that idea, you have to think of the galaxy not as a static sea of stars, but as a dynamic, swirling organism. Every system sheds material. Stellar winds carry dust. Supernovae eject metals. Binary stars pull on each other, scattering planets like seeds. Over time, all those fragments drift together into streams, slow, silent, unending. Some collide, some merge. Some wander alone for millions of years until gravity nudges them toward new suns. Our solar system isn't isolated. It's a harbor along one of those invisible rivers. Every few centuries, something from those streams passes through. An interstellar letter addressed to whoever happens to be watching. The arrival of 4I confirmed what Atlas had only suggested, that we are connected to other worlds in ways we barely understand. That interstellar travel doesn't belong only to intelligence, it belongs to matter itself, and maybe that's the real message. The universe doesn't communicate in words or codes, but in patterns, repetitions, coincidences, resonances. It's not speaking to us exactly. It's just being itself. But sometimes being itself is enough to sound like a conversation. Scientists often describe interstellar objects as messengers. The term isn't romantic, it's statistical. Every visitor carries information from another star system, a record of chemistry and temperature and radiation environment. Studying one is like opening a time capsule. But with Atlas, something changed. It wasn't just data that traveled. It was emotion. It was meaning. By the time 4I appeared, the story had already become myth. People still whispered about the Echo, the strange companion that followed Atlas beyond the sun. Some believed 4I might be the Echo, returning from a wider orbit, reshaped by its journey. The math didn't agree, but the poetry did, and sometimes poetry gets there first. Meanwhile, the instruments told their own story. 4I's spectra contained faint traces of metals, magnesium, iron, even hints of nickel. That was unusual for comets, which are usually rich in volatiles but poor in metals. The metallic compounds made it behave more like an asteroid, dense, heavy, reluctant to shed a tail. And yet when it neared the sun, a faint glow appeared, soft, blue, ionized. The same shade once seen in Atlas's plasma tail, the same breath. The same humdot radio observatories tuned their antennas, remembering what they had heard last time. The faint, coherent oscillations that had haunted the data. And though weaker, though buried in noise, something was there again. A pulse, not constant, not structured, but familiar. If the cosmos has a rhythm, perhaps we were hearing it again. In the days that followed, more data poured in. The object's trajectory confirmed it would pass close to Earth's orbit, close enough for radar pinging. The attempt was risky but successful. The echo, the radar kind, not the companion, returned faint but clear. A smooth, irregular body, roughly elongated, about half a kilometer long, and just like Atlas, it showed hints of surface smoothness, inconsistent with rubble piles, too reflective, too compact, too deliberate. The same arguments rose again. Was it natural or something more? But this time the scientists didn't rush to speculation. They remembered the lesson of Atlas, that mystery doesn't need explanation to have value, so they observed quietly with patience, letting the universe unfold at its own pace. Because maybe understanding isn't always the goal. Maybe sometimes the purpose of a visitor isn't to answer questions but to create new ones. I passed through the inner solar system in silence. No fragmentation, no drama, no spectacle. It came, glowed faintly, then began its long exit, another traveler returning to the dark. But before it vanished completely, something remarkable happened. One night, as several observatories tracked it simultaneously, a brief flare appeared along its path, a flash of light, gone in seconds. The telescopes caught it by luck. Triangulation placed it not on 4i itself, but a few hundred kilometers behind it, the same distance proportionally that once separated Atlas and the Echo. A coincidence, perhaps, or a signature. Somewhere in the darkness between the paths of two interstellar travelers, something invisible connects them. A field, a resonance, a rhythm older than light. And maybe that's what the pulse always was. Not a signal, not a message, just the sound of the universe exhaling between stars. By the time 4i left, its faint trail of dust shimmered one last time under solar wind. Some astronomers swore they saw patterns in that dust, repeating spirals, echoing waves, almost like fingerprints left on the canvas of space. But when analyzed later, the shapes dissolved into randomness. Or maybe that's just what we call a pattern we don't yet understand. In the end, it didn't matter, because every fragment, every faint reflection, every shimmer of light shared the same origin and the same destination: the dark. And perhaps that's the truest story of all. The universe sends us visitors not to tell us what's out there, but to remind us that we are part of it. That nothing, not even silence, travels alone. That between every beginning and every ending lies an echo, faint but endless, carrying the memory of connection across the void. There's a quiet that exists only in deep space. It isn't silence as we know it, not the absence of sound, but the absence of interruption. A stillness so complete it becomes its own kind of music. That's where 3i Atlas now lives, no longer visible to any telescope, no longer bright enough for even the most sensitive instruments to trace. It drifts somewhere beyond the pull of the sun, a dim ember cooling in the dark. The echo, if it still exists, follows somewhere nearby. Or maybe it doesn't. Maybe the two finally merged, one last gesture of unity before fading from sight. No one can say for sure. But their story hasn't vanished. Because the universe doesn't erase, it reuses. Every atom, every photon, every grain of dust continues the work it began billions of years ago, shaping, moving, remembering. When 3i Atlas entered our sky, it wasn't here to stay. It was here to remind us that we live inside a universe still making itself, that creation never stopped, that every collision, every storm of dust, every wandering object carries the signature of something older, something eternal. For the scientists who studied it, the mystery became a paradox of comfort. The data was incomplete, the conclusions inconclusive, yet the experience left them changed. Some confessed they began to look at the night differently, not as a collection of coordinates, but as a living architecture of relationships. Points that move, paths that cross, systems that breathe. Because maybe that's what Atlas taught us, that the sky isn't a fixed map but a pulse we sometimes mistake for coincidence. The universe, for all its chaos, seems to favor rhythm, the orbits of planets, the flicker of pulsars, the waveforms of light. Everything moves with repetition. It's as though existence itself hums a single endless note, and everything we know is just a harmonic of that original vibration. So perhaps it's no surprise that Atlas hummed too. Perhaps it was only echoing the oldest sound in the cosmos, the background tone of creation, faint but unbroken. When we call it mystery, we really mean intimacy. Because what unsettled us about Atlas wasn't just that we couldn't explain it. It was that it felt close, too close. It mirrored something deep in ourselves, the urge to be seen, to leave a trace, to wander and still belong. The human mind wants stories. The universe gives us phenomena, and somewhere between those two we create meaning. In the wake of Atlas, new telescopes rose, new instruments launched. The James Webb Space Telescope continued its watch, while the Vera Rubin Observatory prepared to map the entire sky every few nights, recording every transient flicker. Astronomers began talking differently. The word visitor entered technical vocabulary. Interstellar stopped meaning distant. It began meaning shared. We once thought stars were lonely. We were wrong. They trade matter. They send fragments. They share dust-like memories. Somewhere out there, the pieces of a shattered world are still drifting. Atlas, the Echo, 4i, and countless others we'll never see. Each one a message written in motion. Each one proof that separation is an illusion, and maybe that's the strangest realization of all. That connection doesn't require communication. The universe doesn't need words. It connects through gravity, through resonance, through rhythm. We feel that rhythm every time we look up, every time a meteor streaks through the sky, burning in an atmosphere it never knew. Every time a comet flares for a few nights before fading forever. Every time we stare into the black and call it beautiful. What we're really seeing isn't destruction, it's exchange. Matter becoming memory, light becoming story. For centuries we've described the cosmos as mechanical, a system of forces, equations, predictable laws. But when something like Atlas appears, it bends that certainty. It reminds us that the universe is not only mechanical, it's expressive. It doesn't just exist. It performs, it paints with gravity, it writes with motion, it composes with silence. And sometimes, when we're lucky, we catch a glimpse of that performance, the way a single visitor can turn physics into poetry. If you think about it, the fact that we noticed Atlas at all is extraordinary. Out of the infinite dark, a rock no larger than a mountain passed briefly through our line of sight, and somehow we recognized it as different. We measured it, recorded it, debated it, but more importantly, we felt it. That feeling, the tingle of wonder, the quiet question of why, is perhaps the most human thing there is, because in the end, 3i Atlas didn't just teach us about comets, it taught us about ourselves, our need to make sense of chaos, our instinct to look for reflection in the unknown, our refusal to believe that the universe could be empty of meaning. Maybe that's what it means when people say the cosmos is conscious. Not that it thinks, but that it makes us think. That it awakens thought wherever it passes. Every generation has its messenger. Ours just happened to arrive as a comet that sang in light. Somewhere now beyond the heliopause, 3i, Atlas continues its drift. The sun has become a faint, distant star behind it. The solar wind has thinned to nothing. Ahead lies the interstellar medium, the quiet sea between suns. In 1,000,000 years, maybe it will pass another star, another civilization, another species wondering if they're alone. Maybe they'll look up and see a faint moving light and give it a name, never knowing that it once passed by ours. And in that moment, across the gulf of time, the story will begin again, because the universe doesn't care who listens, only that the song continues. When scientists look back centuries from now, the data on Atlas will seem primitive, a handful of graphs and photographs, incomplete spectra and uncertain readings. But maybe that's fitting, because the most important parts of its story were never measurable. They were the pauses between numbers, the silences between explanations, the wonder between words. In those gaps, something larger than comprehension lives, something that hums softly, endlessly, the same hum that moves the stars, the same hum that echoes in the human heart when we stare at the night sky and feel that ancient familiarity. The recognition that we are not observers, but participants in the same vibration. The hum is what binds us to the universe and what binds Atlas to us. It was never just a comet. It was a reminder that even in the coldest parts of space, light still finds a way to return. That even in the absence of certainty, meaning survives. And that even across the emptiness between stars, there is rhythm. Patient, infinite, waiting for ears willing to listen. So tonight, as you close your eyes and drift towards sleep, imagine this: somewhere far beyond the edge of our maps, two silent travelers glide through the dark. Atlas and its echo still moving in unison, still resonating with the faint heartbeat of a universe that refuses to die. And if you listen closely, beneath the noise of your thoughts, beneath the hum of your own pulse, maybe you'll hear it too. That faint, endless whisper from the stars, telling you that everything that ever was and everything that will ever be is still connected, still singing, still home. Long after the light of Atlas faded from our telescopes, the questions it left behind continued to orbit us, invisible but persistent. Every generation leaves its riddles written in the sky. And maybe Atlas was ours, a riddle not meant to be solved, but remembered. Because in the years that followed, something subtle began to change. Not in the data, but in the people reading it. The scientists who once spent their nights staring into noise began to describe their work differently. They stopped talking about objects and started talking about events. They stopped saying the comet passed and began saying the encounter occurred. That single shift from thing to experience changed everything. It made them realize something profound, that astronomy is not the study of space. It's the study of connection. Every photon that reaches us has traveled across unthinkable distances, carrying not just light, but context. The moment we detect it, we participate in its journey. We become the last link in a story that began billions of years ago. So when we looked at Atlas, we weren't just observing it, it was observing us too. Not consciously, not deliberately, but physically. Its light touched us. Its dust entered our atmosphere. Its trajectory changed because of our sun's pull. For a brief moment, we were written into each other's stories. That realization changed how some scientists viewed their role. They stopped seeing themselves as detached observers and started seeing themselves as instruments, extensions of the universe trying to understand itself. The telescope wasn't just a tool. It was an organ of perception, a way for matter to look back at its own reflection. In that sense, Atlas wasn't just a comet. It was a mirror, showing us what it means to exist in relationship to something vast, uncontainable and real. Even now, its dust continues to move through space. Tiny grains invisible to our eyes, crossing the orbits of planets, mixing with interplanetary wind. Some will enter Earth's atmosphere centuries from now as shooting stars, brief streaks of light that burn for a second, then vanish. When that happens, a child might look up and make a wish, never knowing that the light they see came from the remnants of an interstellar traveler, a piece of Atlas, completing its final act of contact. And maybe that's what contact has always been. Not conversation, not messages, just touch. A grain of dust meeting a world of air, a spark bridging the void. In one research paper published years after the comet faded, a physicist described the phenomenon in poetic terms. Perhaps the universe does not send visitors to teach us, but to remind us that we are visible. That line stayed with me, because that's what this entire story has been. A reminder that we are not invisible to the cosmos. We exist inside its field of perception. We bend light, we cast gravity, we echo. To imagine ourselves small is to misunderstand scale. The universe isn't measuring size, it's measuring participation. Every star is a story, every orbit a sentence, every comet a word that can only be spoken once, and together they form the language of existence, a language we're just beginning to hear. When we recorded Atlas's hum, we thought it was data, a set of oscillations meaningless until analyzed. But now, years later, those who listen to the playback describe it differently. They say it feels like breath, like something inhaling and exhaling across time. Maybe that's not metaphor. Maybe the universe itself breathes, galaxies expand and contract, stars flare and fade. Life appears, evolves, and dissolves back into silence. Every pulse, every echo, every rhythm, it's all part of the same respiration. A cosmic inhale, a cosmic exhale. Atlas was a single breath among trillions, but we were the ones lucky enough to feel it pass through us. Somewhere in a university lab, a researcher once simulated Atlas's trajectory backward, tracing its path through interstellar space. The line curved gently through the Milky Way, past clusters of stars and regions of dark molecular clouds. Eventually, it crossed a field of radiation scars, a place where a supernova had once exploded millions of years ago. That may have been its birthplace. A fragment of a system destroyed, carried outward by the blast, crystallized in vacuum, and flung into the long migration that ended in our sky. A journey of light years reduced to a few weeks of visibility. A lifetime compressed into a glimpse. It's hard not to see the metaphor, because that's all life is, a short visibility in the darkness. We appear, we burn, we fade, and yet we matter, because even the briefest flame changes the landscape around it. If Atlas had never arrived, we might never have known what questions to ask. We wouldn't have built the instruments, run the simulations, or listened for harmonics in the silence. We wouldn't have noticed the patterns that came after. It's strange to think how one visitor can alter the trajectory of an entire civilization's curiosity. But it did. In a way, Atlas gave us permission to wonder again. It reminded us that not every anomaly is a glitch. Some are invitations, and that maybe the universe is not a puzzle to be solved, but a presence to be felt. Sometimes late at night, when observatories fall quiet and data streams go still, astronomers step outside their domes and look at the stars with their own eyes. No instruments, no filters, just vision. They breathe in the cold air and realize that they too are part of the same network of matter, that the atoms in their breath were once plasma in a sun, dust in a comet, carbon in a dying star. We are not separate from the cosmos. We are the way it sees itself. Atlas only reminded us of that, the same way a whisper reminds you that you're not alone in the dark. And maybe that's why so many people found peace in its story. Because even though it came from elsewhere, it felt familiar, like something we had always known, returning to us in a new form. Perhaps that's what all discovery is, recognition disguised as surprise. We don't find the universe, We remember it. So if you ever look up one night and see a faint streak crossing the sky, pause for a moment before calling it coincidence. That light has traveled longer than you can imagine. It carries not just photons, but history. And somewhere in that light, faint but persistent, lives the echo of a visitor that once made the world look up and listen. Iconic Atlas. A name that became a myth that became a mirror that still reflects us even after it's gone, because maybe, in the end, that's what the cosmos is. Not a mystery waiting to be solved, but a reflection waiting to be seen. And if we learn to see it clearly, maybe we'll realize the simplest truth of all. The universe has never been silent. We've just been listening in the wrong language. Years passed. The world moved on. But somewhere in that quiet motion of time, the story of Atlas continued. Not in headlines or observatories, but in the hearts of those who still looked up. Because some mysteries don't end when we stop observing them. They end when we stop remembering them, and Atlas refused to be forgotten. Every generation inherits a few moments that change the way it sees the sky. For some, it was the first step on the moon. For others, the first photograph of a black hole. And for this generation, it was a comet that came from nowhere, sang without a voice, and left without goodbye. In the years after Atlas faded beyond the sun's reach, the data it left behind began to mature, like seeds that sprout long after being buried. New analysis techniques, powered by quantum computing and AI-driven spectral reconstruction, revealed things the original researchers couldn't. Hidden within the noise of the brightness curve were faint harmonic traces, subtle, repeating frequencies that had gone unnoticed for years. When converted into sound waves, the patterns resembled something familiar, resonance across octaves, each pulse multiplying like echoes in a canyon. They called it structured randomness, chaos with a rhythm, disorder with a pulse. And in those harmonics, the story of Atlas took on a new dimension. The discovery was small by scientific standards, but enormous in meaning. Because those harmonics matched the plasma frequencies of the interstellar medium, the same background resonance that hums between stars. It meant that Atlas hadn't just passed through the cosmos. It had sung with it. It wasn't the source of the hum. It was part of the choir. And suddenly 1,000 theories that once seemed poetic began to feel like physics. Perhaps Atlas didn't hum because it was unique, but because it was tuned. Perhaps every interstellar traveler vibrates with the same ancient melody, the fundamental tone of the universe itself. To some, that was data. To others, it was revelation. Scientists who once laughed at metaphor began using it without irony. They spoke of resonant identities, field memory, cosmic continuity. For the first time in centuries, the language of science and the language of awe began to overlap again, cautiously, quietly, beautifully. And in that overlap, something ancient stirred. Humans had always looked for music in the heavens, from Pythagoras' music of the spheres to Kepler's harmonic ratios of planetary motion. But now the metaphor had returned as measurement. The harmony was real. It wasn't just philosophy. It was physics. The same resonant frequencies that connected galaxies also shaped the internal oscillations of atoms. The same pattern that governed Atlas's pulse echoed in quantum interference, magnetic reconnection, and the flicker of pulsars. The universe was built on repetition, a structure of resonance from the smallest vibration to the grandest motion. One physicist described it like this: "We used to think of the universe as a machine. Now we think of it as a song. That idea changed everything, because songs are not static. They evolve, repeat, blend, and return. They carry memory not in matter, but in rhythm, and that meant something incredible. That memory might not belong only to life. It might belong to the universe itself." The resonance model suggested that energy fields could retain structure long after matter dispersed. In other words, every motion, every vibration, every pulse leaves a faint imprint on space-time, a kind of echo that never fully fades. So perhaps, somewhere in the cold expanse where Atlas now drifts, those imprints still exist, the faint memory of its journey etched into the electromagnetic silence. Not alive but not gone, just continuing. It's strange to think about, a ghost made of resonance still moving through space, still humming the same song it once sang near our sun. Maybe that's what immortality looks like in the language of physics, not the persistence of form, but the persistence of pattern. And maybe that's why we feel drawn to it, because we're built the same way. Every heartbeat, every neural oscillation, every breath is part of a rhythm larger than us. Our lives are short, but our patterns, the vibrations of our atoms, will continue. Carried forward into other forms, other songs. We call it death, but the universe calls it modulation. That realization didn't make the scientists less rational. It made them quieter. They began to see their work not as discovery, but as participation, a duet between mind and cosmos. The act of studying the universe became a form of listening, and listening changed them. One night, a team at the Rubin Observatory ran a comparative simulation between Atlas and 4I, the later interstellar object that followed its path. When the brightness curves were aligned, a strange coincidence emerged. Their pulses, though separated by years, matched across a precise harmonic ratio of 3.2. 3 pulses from Atlas aligned perfectly with 2 from 4I. That ratio wasn't arbitrary. It's one of nature's most fundamental intervals, the same harmonic relationship found in the vibration of strings, in orbital resonances of moons, in the rhythm of heartbeats. It was impossible to ignore. 2 interstellar travelers separated by light years and time, yet moving in mathematical harmony. Coincidence? Almost certainly. But still, a coincidence in tune. And for some that was enough, because maybe that's the real lesson Atlas left behind. Not that it was special, not that it was alien, but that everything from atoms to galaxies participates in the same silent music. We just forget to hear it. As decades turned into centuries, the archives of the early interstellar visitors became mythic. Students studied them not for conclusions, but for perspective. The story of Atlas became a parable of curiosity, humility, and reverence. And somewhere along the way, the lines between science and spirituality dissolved again. People no longer argued whether the universe was alive. They simply accepted that it behaved as if it were, and maybe that was enough. In that acceptance, something beautiful returned, the sense of belonging. We are not standing outside creation, looking in. We are within it. We are made of the same rhythm that moves the comets and folds the light. The more we listen, the more we realize that the universe doesn't just surround us, it includes us. We are one of its verses. So when the next interstellar traveler comes, and it will, maybe we'll greet it differently, not as a subject to study, but as a voice to join. Because the lesson of Atlas was never about what it was. It was about what it awakened, the memory of connection we had almost forgotten. In the end, maybe that's what the word interstellar really means. Not between stars, but among them, together, resonant, alive. And if you listen, really listen, you can still hear the last note it left behind. Not in the instruments, not in the data, but in the quiet between thoughts. A whisper that says you were never alone. You never will be. There's a point, somewhere beyond the edge of our solar system, where sunlight stops being light and becomes memory. The photons thin out. Shadows no longer exist. Space folds into itself until there's no direction left to face. Only distance. That's where 3I Atlas drifts now. No tail, no shimmer, no sound. Just motion. Slow, constant, eternal. It's strange how something so far away can still live so vividly in the human mind. We can't see it, We can't hear it. Yet we feel it, as though the memory of its passing left a trace in us, like the afterimage of a light that burned too beautifully to forget. Because even though it was just a fragment of ice and dust, Atlas carried something larger than itself, a story written in silence. And once a story enters the human imagination, it never really leaves. It becomes a part of how we see the world. That's what happened with Atlas. It changed the way we look at space, the way we think about beginnings and endings, and the way we define life. When it first arrived, we called it a mystery. But now, years later, it feels more like a mirror, showing us not what we found, but what we were ready to see. It reminded us that we are not separate from the things we study, that the act of observation changes both observer and observed, that maybe the very reason the universe produces consciousness is so it can finally witness itself, because that's what we are in the eyes of the cosmos looking back at its own unfolding. Atlas didn't visit us, we met it. Two moments in time colliding, briefly sharing awareness before drifting apart again. And maybe that's all connection ever is. Coincidence seen from the right perspective. There's something deeply comforting about that. The idea that even the briefest intersections between stars, between lives, between fragments of thought, leave permanent ripples in the fabric of existence. Every word ever spoken, every movement ever made, every flicker of light in every galaxy, all of it contributes to the same vibration. A vibration that doesn't end. It only changes form. That's what scientists now believe about the hum, that low, omnipresent resonance first recorded from Atlas's light. It isn't a signal. It isn't communication. It's the sound of continuity, the echo of energy becoming matter, and then returning home again. If you could listen to it, really listen, you might hear the story of everything that ever lived. Not as language, but as rhythm. The pulse of hydrogen forming stars, the breath of planets cooling after creation, the heartbeat of every organism that ever looked up and wondered, who's there? In that hum there is no separation, only variation. Every being, every object, every star adds its own note, creating a harmony so vast we can only experience it in glimpses. A comet that sings, a photon that hums, a human heart that responds. When we looked at Atlas, we were not just observing, we were harmonizing. Our attention became part of its resonance. Our wonder became part of its song. And that means something profound. That meaning is not found in the universe. It's created with it, in collaboration, in resonance. We often speak about listening to the universe, but maybe the truth is more intimate. Maybe the universe listens through us. Maybe our curiosity, our awe, our longing, are all ways the cosmos hears its own beauty reflected back. Because what else is science, if not love, in the language of observation? And what else is wonder, if not memory returning to itself? Sometimes I imagine what it would be like to follow Atlas, to drift beyond the planets through the cold, through the endless dark, to see stars rise and fade across millennia, to watch galaxies turn like lanterns in an infinite ocean. It wouldn't feel lonely. It would feel familiar, because in the grandest sense, we've all been there before. Every atom in our bodies has traveled through that same dark, forged in dying stars, scattered by explosions, carried on cosmic winds before finding each other again on a tiny blue planet. We are not new, we are rearranged. The universe doesn't create life, it rearranges it, endlessly, beautifully, patiently. Maybe that's why Atlas felt alive, not because it was conscious, but because it reminded us of the continuity we come from, the persistence of existence that never truly stops. And maybe that's the real secret of interstellar visitors. They're not strangers. They're reminders. Reminders that creation never ended. Reminders that motion is memory. Reminders that even in the coldest reaches of space, light finds a way to move forward. That's why the scientists who tracked Atlas no longer describe it as lost. They call it in transit, because nothing that exists is ever truly lost, only moving between forms of visibility. Somewhere in that invisible dark, the nucleus of Atlas is still orbiting the galactic center, still traveling the spiral arms of the Milky Way, still singing in frequencies too low for us to hear. It may pass near another world someday, another sky, another species that looks up and wonders, and when they see it, they'll give it a name of their own. They'll chart its path. They'll listen to its hum. They'll ask the same questions we did. And maybe, for a fleeting moment, their story will intersect with ours, not through distance, but through rhythm, because rhythm is timeless. If you've ever stood beneath the stars and felt your heart beat a little slower, felt that strange calm, that inexplicable sense of belonging, that's the rhythm we share. That's the hum finding its way through you. It doesn't matter where you are or who you are or how much time has passed. The hum is still there. It always was. It always will be. Maybe one day, when our own civilization is gone and Earth itself is dust, another traveler will pass this way. It might find fragments of us, a radio signal still echoing, a probe drifting between planets, a memory encoded in light. And when it does, perhaps it will feel the same thing we felt when we saw Atlas. Recognition, not of shape or sound, but of resonance. The acknowledgement that we are not separate notes, but parts of the same song, the same pattern of light moving endlessly toward itself. In that realization lies peace, because it means nothing truly ends. Atlas didn't end. The echo didn't end. Even we, temporary, fragile, finite, don't end. We continue as vibration, as memory, as part of the hum. So if you're listening to this, wherever you are, whenever you are, take a moment to close your eyes. Breathe. Feel the faint rhythm beneath your chest. That pulse, that gentle thrum of existence. It's the same one that moved through Atlas, through the stars, through the birth of everything that ever was. You are not outside the story. You are within it. You always were. The universe doesn't speak in language. It speaks in continuity. And tonight, if you listen closely enough, you might just hear it whisper back, "I remember you."